Today, we're going to talk about derivatives and how to evaluate them. All a derivative is the rate of change of a function. In other words, this is delta y over delta x, which is the change in y over the change in x. This is the rise over the run. When the rate of change is constant, we know that to be slope. So say we're given a line when the rate of change is in fact constant. We can find the slope or the rate of change given two coordinates, x1 and y1, x2, y2. So if we're given two coordinates, x1, y1, and x2, y2, we can find the slope by taking y2 minus y1 over x2 minus x1. So the slope. And since the slope is constant for all coordinates of x, since this is a line, this is always correct. But if we want to find the rate of change of a function that is not a line, and that doesn't have a constant rate of change, such as this function. So let's name this function fx. So say this function is fx. It clearly doesn't have a constant rate of change. So how do we find the rate of change? Well, we can use a similar tactic that we employed to find the slope of the line. We have this point x of it, and the y-coordinate at this point x would be f of x. And if we are given another point, x plus h, the y-coordinate at that point would be f of x plus h. So we're given 2 points, x and fx, and also x plus h, and then fx plus h. And this, so we can employ the similar tactic and use f x plus h minus f of x over x plus h minus x. This equals f x plus h minus f of x over h. But we're not done here. We have this interval here, h. And since the rate of change, or the slope of the tangent line at a given point, is not constant, to be as accurate as possible, we need this interval to be as small as possible. In other words, we set the limit h going to 0. As h gets smaller and smaller, as h reaches 0, x plus h gets closer and closer to x. So we set the limit h to 0, and then fx plus h minus f of x over h. And this is the general formula to find the derivative of a function. If we're given a function, f of x is equal to x squared, how do we find the derivative of that function? Well, we know that the derivative of fx, which is noted as f prime x, is simply equal to limit h to 0, fx plus h minus fx over h. And f prime x signifies the derivative of fx. So given fx is equal to x squared, to find the derivative of that, we do f prime x squared. This is equal to limit h going to 0, f x plus h, or sorry, not f, just x plus h whole square minus x squared over h. And this might look as h is going to 0, that this function becomes indeterminate as we have a 0 on the bottom. But through some manipulating, we can eliminate terms and eventually remove the 0 on the bottom. So expanding this out, this equals x squared plus 2xh plus h squared minus x squared over h, and the limit is h going to 0. This equals limit h going to 0, and the x squared terms get canceled out. So we just end up with 2xh plus h squared over h. Now we can factor it out, factor h from the numerator out. So we have h times 2x plus h over h. The bottom h and the top h cancel out, and we're just left with limit h to 0, 2x plus h. And now it's a simple process of just plugging 0 into h, which is equal to 2x. So we're given that if fx is equal to x squared, f prime x, the derivative of x squared is 2x. And we can do a similar thing, plugging it in and evaluating for all derivatives.